on this episode of Star Talk. It is Star Talk Live at Pioneer Works in Brooklyn. My comedic co-host is Paul Mercurio, and our special guest is cosmologist Janna Levin. And we talk about my latest book, co-written with our longtime senior producer of Star Talk, Lindsay Walker. And after that, we talk about Einstein's greatest blunder. We talk about Edwin Hubble, the man, not the telescope, and a lot more coming up on Star Talk. First up, the humor part comes from a professional stand-up comedian who's a participant in practically every episode that we post. Tonight, we have our friend and one of my favorite comics around, Paul Mercurio. Paul, come on up. Where are you? Good. See, Paul, you got a podcast of your own.
I do.
And it was creatively called what?
It's called, see, he's insulting the title of my podcast already. Inside Out with Paul Mercurio.
Inside Out with Paul Mercurio.
Yes.
Okay. All right. I've been a guest on his podcast.
And we had a great time at the planetarium.
Yes, we did.
Yeah.
Yes. Yeah.
And then a few drinks, and we broke a couple of things. But
that's right.
No.
So thanks for coming on.
Thank you for having me.
This event.
Is a live thing. This is an amazing space. I've never been here. This turnout's amazing. I'm really excited, and then we're all going to go swimming after this. Just right.
Well, in the East River here, you're saying. Okay. Next up, we all know and love her as Janna. She is Professor Janna Levin. Janna, come on up. Janna Levin. Does she need an introduction in this space? I don't think so, but we'll do so anyway. So you're Tao Professor of Tao?
Tao
Professor of Physics and Astronomy at Barnard College of Columbia University.
Where we first met.
It is. And you're Director of Science here at Pioneer Works, Brooklyn in the house. Yes. Editor-in-Chief of the Pioneer Works podcast. Author of How the Universe Got Its Spots, one of my favorites. Black Hole Survival Guide.
It doesn't end well, just, spoiler alert.
You don't survive that, okay? And also one of my favorites, The Black Hole Blues and Other Songs from Outer Space. That's how you want me to say it.
All the time. I want you to say it all the time.
The Black Hole Blues. And so, in fact, tonight, we are going to focus on the fourth section of the book, which is really where the title of the book takes shape, To Infinity and Beyond. Places where our bodies can't go, but our minds can. So, let's begin here right now in Brooklyn. Let's do it. All right. Okay.
I love being a guest on this stage, by the way.
Oh, yeah. No,
I love that you're the host. This is so fun for me.
I got you. So you can just chill.
Yeah.
And we have questions for you for us to understand. So in the book, it's about upheavals in our understanding of how the world works and how we reacted to that. Were we elegant and graceful, or do we get dragged into the future kicking and screaming? Not all stories in the history of science have smooth, sort of journalistic, burn the midnight oil and say eureka at the end. So let's detail some of the weirdest, wackiest ideas in the universe. And you got to start with who?
Einstein. That was just a good guess.
Yeah, so his theory, special and general theory of relativity, and you're an expert on that, right?
Oh, absolutely.
Yeah, just checking. So tell us about Einstein's biggest blunder. And we talk about this in the book just because this is some of the fits and starts that we go through to understand the universe. So what's going on with this?
I love this about him because here he is dreaming these dreams that defy everything everyone else took for granted. But then he has a moment of resistance, and it's emotional resistance. He wants to believe the universe is permanent, that it didn't have a beginning and it won't have an end, and that it's static. He wants that. That's an emotional response. And even in his own mathematical theory, he's surprised when other people study it and tell him it predicts a beginning of the universe and an end to the universe.
His own theories
His own
predicted
theory.
it, and he couldn't handle it.
He couldn't handle it.
He couldn't handle
Well,
the
did
truth.
you ever stop?
Couldn't handle the
but
truth.
maybe he just was exhausted at that point. He's like, I've done all this. I know some of it's wrong, but I need a year off. I need some drinks. Like maybe that was the issue for the guy.
Well, crazily enough, the guy almost can't be wrong even when he tries. So he introduces what he calls the cosmological constant, which is just a term that's mathematically consistent with the general theory of relativity. But he declined initially to include it because it made no sense. It came out of nowhere. He couldn't explain it. He couldn't justify it. But what it allowed him to do mathematically was precariously balance the universe so that it was static. But it was very, very unstably so. And when he realized that, he was like...
Right, so just so people are on the same page, I know you guys are scientifically literate here, but just to make sure, you can balance a marble at the top of a hill, and that's a point of equilibrium, but it's not stable. Because any gust of wind will send it one way or the other.
Yes, and in this case, the gust of wind would send the universe contracting or expanding.
Whereas if the marble were at the bottom of a hill, it's also a point of equilibrium, but it's stable because you can displace it and it'll always return to that spot.
And that's what he was hoping for. He was hoping that if you tried to make the universe expand or contract, not be static and permanent, that it would actually prefer to stabilize. But it doesn't. It's actually very, very hard to stabilize the universe. And as we know today, the universe is in fact expanding.
So Einstein was an idiot, you're saying? Yeah.
But what was it? I mean, there's a quote in the book where you say, with the notion of a static universe firmly anchored in its philosophical substrate, Einstein developed his general theory of relativity, and it embodies his assumption of a stagnant universe, even though his own equations reveal the unsettling truth. So he must have known. Why couldn't he get his head around that reality?
Well, I think nobody really knows. I don't know if there was really a sense of investigating with him why he was so resistant to the predictions of his own theory.
Can it be really his fault? Who would have been the first to say the universe has a beginning? I mean, religion said it, but scientifically, there's no reference frame to even have that thought.
No, it's really stunning. It's the first time there's a scientific concept of a beginning, a Big Bang, beginning of the universe.
Listen, I think it's clear the guy was closed off emotionally. And
you got the analysis. So tell me about Lemaitre.
They looked at Einstein's equations, which he wrote down after lots of fits and starts. He used to say things like, if you think you have troubles in mathematics, mine are greater. It's amazing he kind of made it into the canon, really, that he wasn't just sort of forgotten and excluded.
Yeah.
But he's studying this and he says, if I imagine a universe where everything is kind of smooth and uniform, the whole universe, and I ask, how does space and time respond to a universe full of stuff, as long as it's kind of smooth? It's a very simple system, but not that far off from actually what we observe. But he realized that in response to a universe full of stuff, it wants to either expand or contract.
All right, so...
It doesn't want to just sit there.
So did he finally agree to this?
Einstein, yeah. He agrees after Hubble in the 20s.
Hubble the human being.
Hubble the human being, after whom the satellite is named.
Yes.
Is up
it's not
there.
just a satellite.
It's pretty...
It's a telescope satellite.
It's a telescope satellite. It is
Thank you.
An amazing phenomenon. Hubble looks out at a smudge on the sky, and he's not sure what it is, and he's trying to figure out, is it a nova, which would be a nearby object that's very bright, or is it a distant galaxy and much brighter and much more distant? And there's an actual plate, photographic plate that he took where he crosses out NOV, and he writes VAR with an exclamation point, a variable star. And it makes him realize, because of his understanding of variable stars, that it's a bright object far away.
Very far away.
And that's based on Leavitt, right? Henrietta Leavitt's work.
Henrietta Leavitt's work, yeah.
Classified this variety of variable star that turned out to be crucial to understanding the distances to objects. So
leave it to a woman. There you go.
Yeah.
Made it happen. Good job.
Great, unbelievable story, actually, about Henrietta Leavitt and all that whole crew of female astronomers around the turn of the previous century. They were called Pickering's harem because Charles Pickering, who was the director of Harvard's observatory, hired them for 25 cents on the dollar after he fired all of the male astronomers because they weren't doing a good job. And he said, my Scotch maid could do a better job, and he hired her, which was Wilhelmina Fleming, and she hired all these women, and they became this cluster of phenomenal observational astronomers. Unsung heroes, they died in poverty, penurious.
And
but
there's a book
Hubble,
highlighting their
yeah,
careers.
Davis Sobel.
Davis Sobel, that's right. Called the Glass Ceiling. No. The
Glass Universe.
The Glass Universe.
We had David here to talk about that book. Yeah, and it's an incredible story, but Hubble knew about that work, which is remarkable. If he did not know about these unknown women and their work that they were doing at the Harvard Observatory, he would not have understood that he was not looking, if you just imagine a light bulb up close, that he wasn't looking at something up close, but he was looking at something much, much brighter that was very far away.
And so we are now in the centennial decade of Hubble's major discoveries, as well as the centennial decade
we are,
of
exactly.
the discovery
it was 1922.
Exactly, of most of the discoveries of quantum physics. So that was a watershed decade right there, the 1920s. So fast forward to 1998, and we discover a value for Einstein's constant.
That's insane. It's insane. So this is what I meant. He can't even make a mistake. So he introduces this thing to try to make the universe not expand. Hubble comes along and says, I saw this galaxy, it's really far away, and then I saw a bunch of them, and they're all moving away from us. The universe is expanding.
The whole universe is expanding.
The whole universe is expanding. We're not at the center. We're just we're also moving away from everything else. It's the whole thing's expanding.
And that calls into question the age of the universe, and if any of those numbers are right, and all of that.
And we find out that not only is the universe expanding, it's accelerating by the power of this term in Einstein's equation. So in fact, the term does exist.
Crazy.
So even when Einstein was wrong, he was right.
He was right. Exactly. So everyone's like, Einstein.
That's badass.
Get rid of that constant. It's a big blunder. And then in 1998, long after Einstein passed, they realized, oh, actually, the only thing we can think of, not just to make the universe expand, but to make it expand faster and faster to accelerate, is the cosmological constant, his biggest blunder.
Okay,
so it turns out to be right.
So if we're expanding, that means yesterday we're smaller than today. And the day before, smaller than that.
And I'm shrinking then.
And if you go back in time, there's got to be a point where the whole universe is occupying one spot. It had a beginning. Oh my God.
That's Lemaitre coming in, which is actually very interesting. I wonder why Einstein was more resistant to the idea of an expanding universe than a Catholic who had to confront the idea that the universe was ancient and had a beginning.
Right.
I mean, I think that's
the beginning part
amazing.
was easy because Genesis is a
right,
beginning.
but not 6,000 years ago.
Yeah.
14 billion years ago.
Yeah, billions of years ago. So if it had a beginning and it's expanding, does the universe have an edge? And by the way, these questions, is that any different from sitting here on Earth and saying, how do I get to the moon? I don't know. Pose the question. And you heard in this exchange that the answers to the theories had to wait for experiments to join the conversation. You can't just sit in an armchair and claim you fully understand the universe. So, does the universe have an edge?
Are you asking Paul or me?
No, Paul, does the universe have an edge?
I think it does. I've been to the edge, and
No,
it's the Hamptons.
Some people have edges.
So in the context of this, in the book, you talk about the human ego, right? And there's an interesting concept there, which really sort of surprised me. And what you say is that given the battles that raged, et cetera, you say, we know the universe is expanding, blah, 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 the ultimate defining barrier between
blah,
space
blah, blah.
and, well, not space. However, yeah, there's a lot of stuff. By the way, the book needs more pictures. It's like, oh, look, a spaceship, woohoo. No, it's a great book to fall asleep. And I think I'm never coming back on this show again. So No, so in all seriousness, this is a quote from the book. We know the universe is expanding, and that expanding from a single point. Furthermore, everything in the universe must obey a speed limit. Reason would dictate that the universe must therefore have an edge. However reasonable though that might sound, it arises from a faulty premise, driven in part by the human ego. And I was fascinated to know what you meant by that, driven in part by the human ego.
Well, an ego, just, are you in the center of everything? The authentic center? If you learn you're not in the center, can you deal with that? Can you handle?
You can.
Because, just think about it. And we detail this once again in our ascent from Earth into the solar system. You say to yourself, we're in the center. By the way, we made calendars not knowing, calendars we still use today, not knowing Earth went around the sun.
Yes, but they're adorable. They have puppies on them.
No, they're all good. So you can deduce a whole lot about the world without telescopes, but one of the things you cannot deduce is that Earth is going around the sun. That's messed up. Okay, that meant we went thousands of years thinking we're in the center of the known universe, fully feeding our ego.
But why wouldn't you? And when there's no proof of anything else, in all seriousness, why, what other premise would you?
You're being too hard on, pre-BCE civilizations.
Neil, what are issues that you have inside of you?
What I'm saying is,
you need a hug.
The whole universe.
Come here. You need a hug.
The whole universe is masquerading as a system centered on us. So we're not given reason to question it because it feeds our ego. When something feeds your ego, you say, yeah, it's probably true. Not asking, well, maybe it's not true. Because maybe it's not true could have the result that you're not in the center.
But think about the ego you have to have as these great astronomers and scientists to say, I'm going to go and look into something that no one else has done and then stand by it and believe in it before anyone else does. So
that's not ego, that's curiosity.
No, but you've got to have an ego to stand by something, I think.
No, yeah, then you're stubborn.
I'll fight you right now.
Yeah, if you have an idea and you stick by it, regardless of the data, go home. That's not what science is about.
Well, that's what Einstein did.
Which is why we discuss not having debates over science, because no scientist worth their salt wants to come in with a notion and be unyielding or unwilling to accept a new idea or adopt it when it's clearly right.
So two scientists in an argument, there's a different contract between them than there is between two people debating on a stage. So that contract is either I'm right and you're wrong, you're right and I'm wrong, or we're both wrong. So we'll argue until we get to the edges of what our data can show, and then we say, I think we need better data. Let's go have a beer.
Yeah.
Right? Said no one ever at the end of a political debate.
But the idea of the infinite universe kind of fell into that category, because when Einstein was first writing things down, he was just doing the first pass, so to speak, and he has a famous quote where he assumed the universe was infinite, but he also assumed it was static, and he said something to the effect, only two things are infinite, the universe and human stupidity.
Yeah, best quote ever.
And then he added, and I'm not so sure about the universe.
That's right. I forgot about that.
Isn't it a matter of the observable edge versus?
There's an observable edge, for sure. So we can only see as far as the light has had a chance to get to us.
But it's not a physical edge of the universe.
But it's not a physical edge.
So you can't drive through the universe and say, the universe ends here.
Well, we don't think so, but we're not actually 100% sure. We don't believe that there's an edge any more than there's an edge to the Earth.
To the surface of the Earth.
There's not a sign, welcome to the edge of the universe.
Right. So, if I travel from New York City and I go in a straight line, I don't fall off the edge of the Earth. Right? There's no edge. I make my way all the way around and I come back to New York City again. And that's actually a really valid model for a universe that is finite, not infinite, in which you go into a spaceship, you leave the Earth, you travel in a straight line, you go out of the galaxy, you don't deviate, and you find yourself approaching the Milky Way again with the Earth in front of you. And you've never fallen off the edge of the universe. It's completely contiguous, but it is finite.
So I have to repeat a quote from one of my earlier books. The universe is under no obligation to make sense to you. Tell me about the intersection of time and space, which feels so unintuitive, but actually we exist this way. The example I give is if I say, oh, Janna, I'll meet you tomorrow at 10 o'clock. What's your next question?
Where?
Where? I gave you a time, but I didn't give you a space.
I'd say, are you bringing wine?
So then I say, Paul, I'll meet you tomorrow at Starbucks. Okay? We know which Starbucks, and then you'll have to say,
What time?
what time? So we know this intuitively. So then Einstein stitches them together. Why do people lose their mind?
Well, it's amazing because a lot of things he did were actually really simple and intuitive, but he pushes it much farther, where many people would start to get flummoxed and give it up and just be happy to meet at Starbucks with a bottle of wine. That doesn't really make any sense, but okay, Paul. And but
Always go to one with a bathroom. You can do whatever you want.
So he starts to think, well, I can draw up and down, north and south, east and west. Why don't I just also draw a dimension called time, and then we can just agree on where we are in space and time. And then he kind of pushes that further and further and further until he starts to say, oh, it's a space-time. And it's surely
That's one phrase.
One phrase.
Space-time.
I don't like editors out there. I don't like when you put a dash in there. It's space-time. And
No, paired words have to evolve.
Yeah.
And then they eventually lose their hyphen, okay? But like percent used to be 2 words, then it was hyphenated.
Yeah, in French
now it's 1
it is.
word.
Percent.
But why don't you like the hyphen?
Because it separates space and time in a way that Einstein was trying to transcend.
And in this book, we did not use a hyphen. We have editors that followed suit here.
Nice.
So we got
I love it.
National Geographic editors. That's a National Geographic book. Okay, so what that means is that if time is a coordinate, it can stretch or shrink. So you have different rates of time. Christopher Nolan did that in the movie Interstellar.
Yeah, which was by our friend, the original treatment was by Kip Thorne.
Yes.
Who's going to
A
probably
physicist.
come up in conversation
Yeah,
today.
he's your counterpart at Caltech.
Yeah.
Yes.
Well, that's a compliment. Thank
Okay.
you.
No. Yeah.
I'll
Totally.
take it.
Totally.
No, Kip was one of the most gracious, elder statesmen of science when I first met him. He was
And they
one of the
made
most
him an
generous
executive producer
people.
of
Yeah.
Interstellar. So that meant you knew the science had some backbone.
And then he won a Nobel Prize. Really weird order of things.
Yes, yes.
Chronologically weird order of things.
Behind that Nobel Prize, the real person was Matthew McConaughey. Gave him all the information. He's a brilliant,
The
handsome
person
man.
behind the Nobel Prize, yes. Yes.
He'd hang out in his trailer, and Matthew would be like, "No, man, that's not how you do it."
Wait. So you have, if you're nearer a significant source of gravity, your time frame slows down relative to other people.
Yeah, that's
freaky.
It's very freaky, but in Einstein's language, it's no more freaky than the fact that my left and my right are rotated relative to your left and your right. In Einstein's language, you can rotate space and time differently than somebody else's notion of space and time.
In a four-dimensional coordinate space.
Yeah, in a four-dimensional space.
Yeah, that's real easy to grab there. Yeah.
That, when you near the black hole, it's as though you're rotating in space-time, just like you could rotate left and right relative to somebody far away. And just as I won't be like, my left is an absolute notion, obviously I'm rotated and it's relative to your left.
If I face you, that's my right.
Exactly,
Yes,
100% rotation. And he says as you near the black hole, you have 100% rotation of your space, if you're far from the black hole,
with
my time that's near the black hole. It's just like my left being 100% rotated
That's
into your right.
freaky stuff.
Yeah.
All right, so what about wormholes and whether we can use that for time travel?
That's Kip Thorne. Or maybe it's Matthew McConaughey. I'm not really sure. I don't know.
Can we do this without a DeLorean?
Yeah.
Which is now, by the way, on Broadway. It's Back to the
No
Future,
way.
the musical, now on Broadway. Yes.
You really said that as though you were promoting it.
He's got a piece of the
Well, just a quick point there to your space-time fact. Just want to slip this in because we have it in the book. If you go in a time machine and say, I want to go back 3 days. So you go in and then you step out and it's 3 days earlier. you would be in the vacuum of empty space because Earth is in a different place.
But why is it empty? It's still Earth. Why are you in a vacuum of
Because Earth is in orbit around
And the
the sun.
atmosphere went with it.
Earth isn't, you just went back in time, but Earth was in an orbit. You go 3 days back in time, you didn't say, keep me on Earth and do that.
And the whole solar system moved.
The whole solar, so if you actually want to go back in time and show up on this stage, you have to go back in time and in space so that the Earth is where you need it to be at that time. So the space-time thing is real. If you want a time machine your way around the galaxy. Now they got around this in Back to the Future because he jumps into the car, quickly types in a thing, and he goes back exactly 30 years.
So he's in the same orbit.
The
It's same point
Earth
in the orbit.
would have been in the same spot in its orbit.
But did he also calculate for the fact that the whole solar system is rotating around the center of the galaxy?
For 30 years, no. He left that one out. You got to give him a
Well,
hall
it's not
pass.
very much.
They got one of those
It's not
right.
What
very
is
much.
magical about 30 years in that scenario?
It's just
Because it goes, it goes
any
from
years.
1980, no. In that scenario, it goes from 1985, the year of the film, to 1955, which is a very fun setting to put a movie in, okay? Because teenagers are coming of age, so...
Chuck Berry's music gets stolen. It's a great time.
Oh, Chuck Berry's music, do you know, who has not seen Back to the Future? Okay, a hand went up. Security, could you take this person out? No, just a quick point about Chuck Berry's music. Marvin Berry, the brother or the cousin, was he the cousin? Okay, hears Marty play Chuck Berry, but that song isn't written yet. He holds up the phone for Chuck Berry to hear Marty play this Johnny B. Good song. Was it Johnny B. Good?
Yeah, exactly.
To play it. And he says, Chuck, this is the sound you've been looking for. Okay. So holding aside that it credits a white person for giving music to a black performer, holding that aside.
That's exactly what I was going to
You're
say.
holding a lot aside. That's a tsunami.
Holding that aside, there's something called a gin particle. Do you know about gin particles? These are things that are neither created nor destroyed. And they involve the time continuum. It's a loop in time where that song in that movie was never written. It only existed to be handed into a time loop. And we call it gin particles because you can hand a person something that you then give to me later in time, and that was never created nor was destroyed.
Oh, but when she hands you that later in time, you can't say that it wasn't invented previously.
No, because I go back in time and give it to her. This is the time travel enables gin particles to exist.
So this is along the lines in the book where you talk about sort of you go back in time with a spaceship, and just before you're about to leave, the day before you blow up the spaceship, right? And then you've got...
I wouldn't do that, but yeah, go on. Yeah.
Well, it's in your book, sir.
Yeah. No, it's a scenario. Go on.
And so where you're talking about parallel universe, right? And sort of how things break off.
Yes.
Right?
Yeah. That's right. So can we travel backwards in time authentically?
Well, this is all interesting related to it because you're assuming that the person who traveled back in time could make a choice that was inconsistent with the physical universe
With what
in which
actually
they
had
live.
happened, yeah.
Right, and Neil, you saying, well, I wouldn't do that, is actually kind of close to the bone because it's really the presumption that we have a free will that could do something that defies the laws of physics. So you can completely go back in time as long as you don't exercise any free will that deviates from the consistency of that universe.
That's what you call in the book the butterfly effect, right? Like you go back in time,
right,
and then you start this sort of ripple, right? But so
that could then change all future events.
Right.
But you don't have the option to do that.
Even if it prevents the birth of you, who then went back in time.
Wait, let's back up.
To prevent that. Wait. So my favorite example of this is I see a friend of mine walking down a corridor, and they slip on a banana peel, okay? And they get hurt. I don't want my friend to get hurt. So I pull out a new texting service that uses particles that travel backwards in time, tachyons. And so I send a text backwards through time so that my friend receives the text before he steps on the banana peel, and therefore they don't fall. So I do that.
But what if he has his phone on airplane mode and he doesn't get the text?
Well, let's find out. So I send the text back. My person feels the vibrate, picks it up, looks at it, and it says, watch out for the banana peel. But while they're looking at it, they don't see the banana peel, and they slip on it. So the very fact that I sent the message back in time is what caused the slippage on the banana peel. And so that's the temporal event laws of physics that you're referencing.
Yeah, strictly speaking, the laws of physics, we know that general relativity has universes, hypothetical, not ones that we've yet observed, in which you can do exactly what you just described, go back in time. But there is no law of physics that we know of that allows you to do so in a way that is inconsistent.
That prevents you from existing.
With the exact path that you are
So
on.
the idea of being able to alter my future by going back in time is...
It's very 12 Monkeys. Yeah.
Ooh.
12 Monkeys?
Yeah, you don't know. You're giving people a
I
hard
missed that
time
one.
about.
I know.
How did you miss 12
I
Monkeys?
remember I saw it, but I
Somewhere in
forgot
between
it.
Now and Back to the Future.
Yeah, I forgot it.
But
Sorry.
could that be wrong?
Could what be
Yes,
wrong?
it
Could that be wrong, right? So there was a refinement of
Could it
the
be
process to
wrong?
figure out the age of the universe, right? Some that started 3 billion and then 5.5 billion or whatever. And to this day, right? There could be some new science that gets discovered that
Yes.
makes this inaccurate, right?
Yes.
What we believe now.
Or some time science.
So there's nothing
that
absolute.
remains to be discovered.
There's nothing absolute.
Never is there.
Other than Neil's handsomeness, there is nothing absolute.
And even Kip Thorne, who's come up a couple of times, who looked at this concept of wormholes. Wormholes were originally proposed kind of like, the battery tunnel or something. It was a shortcut from one place to another. You go under the East River and you connect Manhattan and Brooklyn. Not that weird, right, to find a shortcut to get from one place to another. But what Kip Thorne did, which was exceptional, is he figured out a way to make that shortcut also traverse through time, so that you weren't just traveling from a shortcut from one space to another space, so you didn't have to go the long way around, but you could actually go earlier in time.
Oh.
And they were time travel wormholes. They were time wormholes. But I think if I remember correctly, you could not go back earlier than the
when
time.
you were born.
Oh, no, than the time at which the wormhole was created.
Oh.
Whether you could go, so none of these things forbid the possibility that you could go back in time before you were born, kill your grandfather, the grandfather's paradox, before he had your mother, and then you were never born.
You don't have to kill him. You just have to prevent them from meeting.
Well,
it's so Terminator.
Or slipping on a banana peel.
Yeah, or have them have sex 10 minutes later than they did.
Oh, yeah.
A different person
Okay,
gets
now
born.
I'm throwing up in my mouth a little bit.
Okay, no, sorry. Okay.
It's actually very much like your banana peel story, because a lot of people think that the resolution is that if you went back in time and tried to kill your grandfather, you might just wound him. And then he's so mentally disturbed that when he has your mother, she's tormented and traumatized, and you're so psychotic that you go back in time to try to kill him.
What happened in both of your childhoods? So what you're saying is that the wormhole is like a doorway that has to exist at that point in time, or before that point in time, that you want to travel back to, right?
It was just Kip Thorne's idea for a way to make that happen without altering the entire universe, a way of doing it locally, so that you don't have to think of an entire universe that violates, time moving forward.
Okay,
but
so
you
we're
could do it right here.
We're
You
still
could make it like a
constructing
machine.
the rules of time travel, is what this sounds like.
Yeah.
Okay. Yeah. But traveling to the future, that's no problem.
Oh yeah, I can definitely, obviously we're all traveling to the future. We are in the future from where we were.
At a rate of 1 second per second.
Exactly, and none of us can stop it. It's really weird. I can stand still in space, more or less, but I can't stand still in time. And,
So right now, this is the future. It's not the present.
It's the present, but a second ago when we stood on stage is the past. We have traveled.
We are prisoners of the
traveled.
present, forever transitioning between our inaccessible past and our unknowable future.
That's what happens when you drop acid before a show.
No. All right, so...
Wait, can we just go back to that for 1 second?
Back to the future?
There can't be there is a present.
Yes.
Right now.
Yes.
And there is no future.
I can't say that. So there's questions like, is this like a hill where the future exists already and we're just traveling towards it, but it already is there, like a physical hill? Or is it kind of unraveling in front of us instantaneously. That's not a
we don't
question
know the answer.
Is there a
to.
predetermined destiny that's scientifically based?
That's part of that question. Well, you're not going to stop the expansion of the universe. I would call that a scientific future.
I would say that if it wasn't for the pretty big curveball of quantum mechanics, that the answer scientifically would have been, if not for that curveball that, as you pointed out, happened right at this time a century ago, absolutely predetermined from the second the universe was created. Us sitting here would have been exactly as it had to be. Quantum mechanics is a curveball, but it's not a curveball that really saves us a lot.
So what is deja vu? In all seriousness, like, we all had it, right? Like, we're in a moment where we go, I remember feeling this thing, or it just happened to me the other day, right? So is that somehow tied to this? Could one argue that it's tied to all of this?
Now, George Carlin argued that he has vujade, which is where he goes into a place and he's certain he's never been there before. Okay? So that's me. That's right.
So I mean, to me, this feels in some way, I mean, you're nodding your
Are
head.
you having deja vu right now?
I am. I feel like I was in a place before where Neil was telling that joke.
So we got to bring this to a close here.
Oh, can we talk about the human ego? No, free will. You talk about free will in the book in the context of this.
Yeah, we do. That's a whole.
Yeah, but it's a really fascinating concept.
Well, then they have to buy the book.
Well, I'm helping you sell the book, buddy. Why don't you talk to them? I can't do everything, Neil. I can't write the book. He didn't write the book. Lindsay wrote the book. And
So Janet, take us out. Can you imagine a future of actual wormholes that we create, or warp drives, something to help us move across the galaxy with something other than chemical fuel rockets?
Yeah, I actually can. Now, but it's really, so just like you build a bridge, under the water between Manhattan and Brooklyn, you have to think about a tunnel
Under the water.
To me, they're all bridges.
wow, you just lost a lot of credibility with me. I'm not being a jerk, but I know the difference between a bridge and a tunnel.
Okay.
I'm the smartest one on this stage right now, everybody.
Okay.
Good night.
No.
So you know about the spherical cow. This is kind of like all physicists think anything that connects one thing to another is a bridge. Anything that connects one thing to another is a bridge. And you think about how much energy, money it would cost, and how to do it, like what materials you would need. So very similarly, when Kip Thorne and people like that were talking about wormholes in space-time, they were like, what kind of fuel would I need? And they just made it up. I know it has to have certain properties, it has to repel, it has to keep this open. And they made the wormhole great, but then they looked at the fuel and they were like, we've never seen anything like this in the observable universe. So nobody knows of a fuel or an energy source that can do what the wormhole can do.
But if we had that fuel, we could
do
build
it. Absolutely.
wormholes.
Well, that was my. How does one make a wormhole? And it's very difficult to get contractors to do work. How long does it take to get someone before they give you an estimate and then actually start on the
You're asking me about
wormhole?
the time.
Wait. Plus, wormholes, as I understand it, are unstable. And if you go through a wormhole, they could collapse on you in a moment's notice.
Right. That was a real problem, is it kept pinching shut and separating the two space-times completely. And so you couldn't make it through without being crushed to death or annihilated. But doing that, you can make them stable again if you make up a form of energy that we have never seen in the universe. But it doesn't mean we never will see. I mean, Einstein's greatest blunder, in 1916 was general relativity. When did he write it down? Must have been that same year.
1917.
1917, and it was 19.
It's in
I
the
believe in you.
Okay, good.
You wrote the book.
Okay, good.
No, I don't care. Time. Shut up.
Good.
Wait.
That was good. No, I was impressed.
I made notes.
You didn't
buddy.
have to look at your
I
notes.
made notes. Hang on a second.
You just looked at me.
You talk about the difference between bridges and tunnel. I'll be right back here, right?
Paul, we're proud of you. It's real good.
Let's talk about Seifert variables.
No. So watch. So
The universe finds a way, is all I'm saying.
okay, and it's not any different from going back 200 years ago and saying, in order to get to the moon, we need a fuel that has this amount of energy in it.
Impossible.
They would not be able to fathom that. And you pack all the energy into this tube, and then you can reach. They would say, "What's wrong with you?" Yeah. Okay, so that's what gives me hope that you can make a wormhole in the. We'll go right to you when we have the material, and then that would completely transform transportation in the world. In Star Trek, you wouldn't need the transporter. You just open a wormhole and step down to the planet.
Much less terrifying than having all your atoms reassembled.
Of course, exactly.
Is that doable at some point, you think?
Transporters?
Yeah, to break down your molecules and put them back together?
It's actually been done, technically. They have teleported a molecule from one place to another.
I mean,
a molecule.
Taking the energy that it became.
All of its facts.
And put it over here.
Tossed them over there.
Yeah.
Yeah.
Okay.
And it appeared exactly as it was before.
Now we have a lot of facts about us. It's a lot more information
than just the existence of the
molecule. I know you two do. You got a lot of issues inside.
Right. So just again to close this out and land this plane, this rocket. So I look forward to a future, because that's the whole spirit of the book, where the next wave of what happens is beyond the reach of what we can even imagine building today. That's the beyond infinity.
See, but this argues against your thing in all seriousness about sort of the ego thinking we're at the center of the universe. So when you were talking about sort of how they found a way to invent fuel to go to the moon, it was egoless. It was actually the opposite. It was like striving to find other life, right? So it works against that argument, doesn't it, on some level, about that we're ego-driven?
Wait, you're saying we are not ego-driven because of the example of
I
the
never
moon?
said we were ego-driven.
But I think the example of the moon is very ego-driven because it was very fueled by the Cold War. When the Soviets put Yuri Gagarin in space for the first time, Americans panicked. And they said, the
translation,
phrase,
we lost our shit.
We lost our shit. And that's when when JFK came out and said, hey, space exploration is for all mankind. It was very ego-driven in that sense. So, I mean, we are what we are. We're a product of evolution, and maybe the ego was important in our survival, and here we are.
Or the fact that we can't be contained in a box.
Which is also important for our survival.
Indeed it is.
I've always said that about Neil. You can control him, but you can't contain him. I don't know.
Let that be the last words of this recording of Star Talk. Join me in thanking Janna and our comedian, Paul.
I was screaming. I literally had to yell, just to keep my brain from just running out of the room. Yeah. I knew I wanted to stay in it.
So I was good up to 8 out of the 10, and then 9 was pretty severe. Did you fly into New York to do it?
I did.
Okay, because I just took the subway. Afterwards, I go home. 2 hours later, I had explosive. This is Star Talk. Neil deGrasse Tyson here, your personal astrophysicist, and today is a special edition of Cosmic Queries, coming to you from the hearth of Terry Crews. Terry Crews.
Wait, let's get the hearth going.
What are you talking about?
Let's get this going. Here we go. There we go.
Oh, now it's real hearth. Okay.
Now we got a hearth going.
Fireside chat with Terry Crews. So, Terry, you're my co-host for this episode.
I love this, man.
And we go back, so this should be fun.
This is good, man. This makes my pectorals percolate.
I don't even know how to react.
It's so good.
Watching your...
It's so good. I love learning about science. I love having my mind blown. And just you just always, every time I talk to you, you expand my brain.
Well, you living in the right part of the country, you took up residence in Pasadena, like near Caltech.
That's right.
California
JPL,
Institute of Technology.
Caltech.
JPL, a branch of NASA. So if there's any, you get it osmotically as it comes through.
Exactly. I just feel smarter being here.
No, this is good. And we'll get to the questions in a minute, but I can't channel surf without seeing you on NBC talking about America's Got Talent.
America's Got Talent.
You hosting that.
I'm hosting it. 19 seasons.
And every week you got some kind of new flashy suit.
Oh yeah, well that's part of the whole thing.
Man.
You know, let me tell you, the suit is its own character
yes.
right now. You know, they would be disappointed if I just came out in a gray suit.
I'm ready for the suit to just walk off of your body and do its own dance.
That's right. That's right. I love this show. We just wrapped our 19th
That's
season.
crazy.
I've been hosting 6 of them.
Okay, but I'm looking at it and I say, who are these people? What species are they human?
Yeah.
The stuff they do.
It's amazing.
It's
Well, first of all, last season we had a dog that was the most incredible dog I've ever seen in my life. The dog's name was Rhythm.
That's a cool name. I love it.
Oh, it was. But the dog danced on beat without looking at the owner, Ronnie.
Right, not even prompted.
It was unreal. I was like, I thought it was a man in a suit for a while. I was like, you gotta be, you're lying. It's the best dog act I've ever seen. I always have my brain just blown every time because I think I've seen it all. You know what I mean? You're like,
until you realize you haven't.
And you have not seen it all.
Right.
Never.
Right.
There's no limit to human capability.
And then I realized we got 8 billion people in the world. That's a lot of people with a lot of talent.
That's it.
Some of which is waiting to be discovered. And I wonder, do I have a talent that could work on AGT?
First of all,
You can say no. I got nothing.
No. First of all, you don't know until you try.
Okay.
I did not know that I could act until I was 30 years old.
Oh.
30. I never attempted acting before I was 30, and I did not know it was my destiny. So you might get on there and try something and go, wait a minute.
So we collected questions.
Yes.
We went to our fan base and we said, Neil's hanging out with Terry. What do you have questions for them?
Oh, and they came.
They came in.
Lots of questions.
You got them.
Which is really good. But we picked the best of the best.
Let's come right off the top.
All right. Let's start with, here's Julia Lind. And she didn't list where she's from.
Oh, witness protection. That's what that is.
Yeah.
We don't want it.
Okay.
Julia Lind from somewhere on Earth, we presume. Okay.
Okay. She's come with the questions here. It's hello, Dr. Tyson et al. Is there a possible way to generate an artificial magnetic field on Mars so that it can have a thicker atmosphere and protect colonists on the surface from radiation? It's a 2-part question.
This is deep.
It's a 2-part question.
People thinking all about it. Right. So.
And do you want me to go on?
Go on.
And then she said, is there a technology that we could theoretically develop, or would we be better off trying to build underground colonies on Mars?
Yeah. So what she knows is that here on Earth, we have a magnetic field. Not very strong, but we have one. That's why compasses. Anybody remember what a compass is?
Yeah. Yeah.
Okay.
Old school.
Old school. We have a magnetic field, and when dangerous charged particles come from the sun, we call it the solar wind. Mm-hmm. They see Earth's magnetic field, and then they channel themselves away and funnel in at the poles. And they collide with our atmosphere and render it aglow, causing the aurora. Mm-hmm. So when we see the aurora, that's the atmosphere and our magnetic field shielding us from harmful radiation.
Wow.
Okay. So if we lose our magnetic field, the radiation just comes straight in wherever it hits. Mars, we may have once had a magnetic field. It does not any longer. So if you pitch tent, you're susceptible to this flux of high energy particles. So she was correct to wonder, will we just have underground colonies?
Yeah.
All right. And then I'd wonder, well, then what the hell is the point of being on Mars? We'll live underground. You live underground here.
We'll be basically the ants of Mars.
The worms, whatever. Like, what's the point of that?
Yeah.
Just consider that almost anything will protect you from those particles. Like the roof of a house.
Yeah.
Okay. Yeah. So if you could just, the shielding doesn't have to be elaborate. It just has to have some kind of shielding. And there's a whole branch of NASA. There's a branch that studies the sun and a subdivision of it that specializes in space weather. We call it space weather, which is when is the solar wind coming? Because it correlates with explosions on the sun.
Yeah.
It's not just at any time.
Yeah.
So as the sun goes through cycles, it goes through intense periods and then it quiescent. It's an 11-year cycle. So as it pumps up, we get more warnings about explosions on the sun. And as it drifts off, there's fewer. And we know when a pulse of these particles is going to hit us because it takes time to get from the sun to to Earth or to Mars. So we just have a warning sign.
Yeah.
Is that any different from saying thunderstorms this afternoon?
Yeah,
4
a little
o'clock,
tornado warning.
Tornado warning, bring a umbrella, but this would be a special solar wind umbrella.
Right,
you know?
right.
And so I don't see it as an impossible thing to overcome.
That is cool.
And maybe you create some local magnetic field and direct the particles off to the north and south of you, your little city in a bubble. Whatever. I mean, they could be engineers figure this stuff out.
I love this.
I'm not worried about
I mean,
it.
you know, that is a wonderful thing to say about the magnetic field. It's protecting us.
It's protecting us.
It's so beautiful.
Oh yeah.
You know, but this is another thing I gotta add on to this question. I heard
That's allowed. That's allowed. Okay.
I want to because it's so fascinating.
Okay.
I heard that the magnetic field was actually reversed at one time
Yeah.
in the Earth's history.
Oh yeah.
Woo!
Oh,
That's exciting.
So
north was south.
Okay, so
and
now,
south was north.
Okay, now I don't want to blow your mind.
Okay, hit me.
Okay, really?
I love this.
I say
love
everyone's
this stuff.
mind should be blown at least once a day. That's a quote of mine. Yes. I'm just saying. Okay, you ready?
Hit me.
Okay. We're about the same. I'm a little older than you, but we're approximately the same age. When we were growing up, the North Magnetic Pole was in northern Canada. It was never where Santa is. Whoa. Okay, so Earth's magnetic pole is shifted from our rotation poles. I don't know if you didn't know that?
I did not know this.
And it's not stationary. It moves.
It's moving.
Wait, hang on. So when we were growing up, it was kind of meandering in the Canadian, that whole northern area of Canada where there's just islands and lakes and things. That's where it was, which meant that if you were up in Canada, you couldn't use a compass to find north because it could be south of you.
That's right.
Okay, so it's no good way farther down. You get a kind of right. Good Boy Scout books would have a correction table depending on where you were in longitude. Relative good Boy Scout books. Now watch, you check it lately. That North Pole has been moving, and it is now passing the North Pole on its way to Siberia.
What? Wait.
Yes. And pretty soon it'll be Putin's North Pole.
You're kidding. Yeah. Okay. All right.
The boy controls enough in the world.
That's a tilt. The tilt meter just went.
Okay.
I can't believe it's moving.
Now, on top of all that, the magnetic field is getting weaker. Oh. And we think it's going to get weaker and weaker until it goes away. And then when it comes back again, it'll be in reverse because it flips every time.
Oh, my God.
Now, check this out. You know how magnets work, right? The plus attracts to the minus.
Yes.
Okay, so opposites attract.
That's right.
You've heard that. Okay. If you have a compass with a north, with a little needle, and there's a north side of the compass, that would point to our north magnetic pole. However, that is a north needle on the compass.
Yeah.
Why should north point to north? It's not supposed to.
I know.
Which means Earth's south magnetic pole is in our north. Wow. Because all north magnets point to it.
That's right. That's right.
We're going to point into the opposite.
Oh, my goodness.
So you've always been told that's where our north magnetic pole is. Our south magnetic pole is in our north.
Oh. So
now, so we're going to lose the field, and then it will come back in reverse. Then all your compasses will point the other way. We worry that when the magnetic field goes away to flip again, this is called a dynamo effect. When it goes away and flips, that while it's not there, will it put all of us at risk?
Yeah.
So we go back in the fossil record because it's flipped before. Wow. And if you go to the points where it has flipped, there's no periods of mass extinction. Oh. So if it wreaked havoc, it was not global catastrophe.
Right.
So I'm not so worried about it.
That's deep.
Yeah.
Will our electronics still work?
Yeah, because the magnetic field is not that strong.
So it's no Y2K event.
Not even was that an event.
Yeah, right.
Remember correctly.
Yeah.
Okay, I wasn't worried.
So the threat is not good. Okay, thank you.
Okay.
Thank you.
Oh, by the way, everyone thought like Y2K everything would break.
Yeah.
But keep in mind the way we celebrate time, it's midnight in 24 different hours in sequence.
True.
It doesn't all happen at once.
That's right.
Okay, so it's not like the whole world blows up at once.
Yeah.
Even if that were going to happen, it would blow up time zone by time zone.
It would be one at a time.
So people get confused when they say, "Oh, the magnetic axis is going to flip." They think it's our rotation axis, and then they freak out.
I love this.
So I got to tell them, "No, chill. It's just a magnetic. It has happened before. It's going to happen again.
Listen, man, Neil, you blew my mind on the first question with the first answer.
So Terry, I don't know if you realize the people who ask us these questions, they're part of our Patreon patrons. So they get to ask questions in our Cosmic Queries. So all of them are patrons. So,
I love that.
So check it out. What's next?
All right, next is Sandra Pink. Sandra here from Singapore.
Singapore, very nice.
All right, can't wait to visit Singapore.
I was there a couple of years ago.
I heard nothing but great things. Thank you for doing what you do, inspiring and making everyone's lives just a little bit better every day.
Nice.
Question. Mr. Cruz has so many muscles. Yes, thank you. Sandra, you're the best.
Stop jiggling your
Okay,
pecs.
I'm sorry.
There's
Okay,
not a law against
back
that.
to science.
I bet that's illegal in 3 states.
And muscles are so hard to build and maintain. In the cosmic sense, how important are muscles? And why do we need to work so hard for them if they are so important to our survival? Is this entropy?
Ooh.
Whoa.
Ooh.
I like it.
Well, okay. So there's a lot of speculation about like the strong man in the tribe. Because what does that person do? Goes out and gets the food. Okay, they walk back with an elk on their back.
Exactly.
Okay, and they're the one.
I'm the man.
I'm the man, and I brought back the food. Okay, and there's further speculation that that person has almost mythical significance in the tribe, and everybody wants to mate with that person. Because if you don't want to mate with that person, then you don't have offspring that could possibly do that in the future, and you'll just die. You'll be a dead end in the gene
And very hungry.
That's okay. So people have speculated that this accounts for the fascination we have with famous people, because that whatever was that urge to want to make babies with who brought back the food. Today, you don't need to do that because there's a grocery store down there. So what became of that urge? It's still there within us.
Right.
And there's the person on the silver screen. That's the person who I want to mate with, or I want that to be my friend. There's an urge,
Connection.
even though they're a total stranger. And they could be a total asshole. Doesn't matter. Okay? So muscles have that role. But there are other roles that muscles don't really serve. Okay? So I don't know if everybody had muscles, does that work? So maybe some people out of a group need the muscles for the tribe. And, others need to be able to climb trees nimbly, maybe, to get the fruit. Somebody needs to swim. You surely know how to swim, but if you have less fat, as you surely do, you're less buoyant. Okay? People who have very sinewed muscles are less buoyant in the water. Now, Olympic swimmers, of course, are very sort of lanky. They don't look like you. Okay? Very different bodies.
Not at all.
Okay.
I've seen that.
Yeah, you've seen that. But long distance swimmers typically have a little more fat on their bodies, which gives some buoyancy, so that the energy you're putting into swim is not only to keep you afloat, it's to actually push you forward. Because if you're going to sink, some of your energy has to go into not sinking.
I love what you're saying because it shows that the muscle is skill oriented to what you need.
Yes, it doesn't have to be big.
Right.
Just skills.
It's not about big.
That's correct.
Yes, I love that.
And are you quick? Can you catch the rabbit?
Yes.
And some big muscular person is not catching the rabbit.
Oh, listen. First of all, being
catch a
big,
rabbit?
I've seen for years big guys in the gym who can't do anything.
They can just lift weights.
They're just big.
Big
you know
lift
what I mean?
weight.
I have a perfect example. I thought I was strong, and I had a mover one time. Little guy. I mean, he just looked like a normal guy. And there was a box I couldn't move. I was literally like, hey, man, you're going to need to bring some other people. He was like, no, I got it. And he picked it up and walked out the door. And I was like, oh, my. Because
I like the fact that you benchmarked other people's abilities to your own ability.
What this is the
You
thing.
said, I can't do this. He must need help.
I totally told him, I was like, you better get your friend.
Yeah.
And he was like, no, I got it. And he picked it up and walked out the door. And I realized something. I said, this is what he does.
That's what he does. All his muscles are configured for that.
Everything is configured for moving.
Yes.
I'm not. I'm a celebrity. I don't move anything.
You're a celebrity body.
I love it.
Pop your pecs.
That's it. Thank you, Sandra. Oh, this is great.
Yeah. So entropy is disorder. And generally we like living in what is ordered, and we put energy into a system to order it so that we can function within it. But we have to get that energy from somewhere else.
Yeah.
Things don't get ordered for free.
Wow.
Okay, so we get our energy from the food, and the food gets its energy, if it's an animal, it ate plants, the plant got its energy from the sun. Wow. So ultimately, we are all solar powered.
I love that. That's hot. That is beautiful, man.
It's beautiful.
I tend to lay out in the sun, and I do feel better after I do that.
Okay.
Not too crazy, but but I think that's right.
Communing with the cosmos in that way.
It's a way to keep me grounded.
Yeah.
As you can see, those astronauts stranded in space help us critically think about the origin of life and future of humanity. But with recent advancements in technology, we might not have to worry about human extinction after all. Scientists have found a way to store the entire human genome in a near indestructible 5D memory crystal, enduring extreme temperatures, pressure, and cosmic radiation for a smooth journey through space. When it comes to groundbreaking developments that challenge our understanding of existence, it's important to see how different scientific sources are interpreting the research to fully understand it. Luckily, our partners at Ground News make this much easier to do. With their Vantage Plan, you get access to original reporting plus insight on every article covering it. Ground News provides this level of critical analysis for every topic you're interested in, using patented technology that helps us see important perspectives we might have otherwise missed. Take advantage of their massive 50% discount on their top-tier Vantage Plan and get access to every feature we've shown and more for only a limited time. Use our link at ground.news/startalk or scan the QR code to subscribe. We can't recommend Ground News and their commitment to rigorous analysis enough. Now, back to the show.
All right, give me some more.
All right, here we go. We have Will Mansell Brown.
Mm-hmm.
Hello, Dr. Tyson, Mr. Cruz. New patron here.
Nice.
Another patron. My name is Will Mansell Brown, and I'm from North Hampshire in the UK.
Northampshire. Yeah.
Northampshire.
Northampshire.
Yeah, I got to say it right.
They staple it all together.
Yeah, they do. They do. I'm not from there. I'm not from the UK. Let's see. My question is, photons are massless, however, are given a mass equivalent based on their energies.
Yes, they do.
Does this mean that gamma rays are affected more by the curvature of space than radio waves due to there being a higher mass equivalence? Many thanks, and I love the show.
Wow. Okay. So there's a lot going on there.
Yes, it is.
So the mass equivalent, you have the energy of the photon. You plug it into E equals mc squared. Mm-hmm. You plug it in. Mm-hmm. The E is for energy. You put in the energy, and on the other side is m, mass, times c squared. That's the speed of light squared. That's just a constant. You look that up. Okay. Plug it in. So energy and mass are related in this way. Mm-hmm. So what he's wondering is, if it has no mass, would it still respond to gravity? And if it does respond to gravity, do the higher mass equivalent photons respond more? That's the question. Mm-hmm. Okay. Now that's very Aristotelian, and Aristotle got a lot of physics wrong. Okay. You know what Aristotle said? I'm a little bit paraphrasing. He said, heavy things fall to Earth faster than lighter things in proportion with their mass. He didn't use the word mass, but in terms of their weight.
Yeah.
That's not true.
Like a rock and a feather.
Well, a feather's different. Fine. That's true with a feather, because a feather is doing this. Mm-hmm. But get a heavy rock and a light rock.
Right.
They fall down at exactly the same rate.
That's right.
Exactly the same rate.
Yep.
That is way more profound than most people appreciate. Okay? Mm-hmm. The gravity is pulling more strongly on the heavier object. Mm-hmm. But it takes more force to accelerate the heavier object at the same rate as the lighter object. So they fall at the same rate because Earth is pulling more strongly on the heavier object. Okay, so let's back up. So I have something light, everything's on wheels, and something massive and something not massive. Put the same force on each thing. Mm-hmm. On the low mass object, it's going to scoot along real fast, right? Yeah. And the heavy one's not going to go very fast, okay? So if the force of gravity were the same on every object, you're putting the same force, then the lighter things would go faster.
Right.
The force of gravity is stronger on the heavier object.
Yeah.
Because if the heavier object and the light object are both accelerating at the same rate, something's pushing that harder.
Yeah.
So that they all show up
power.
at more.
Yep.
Okay. So even though gamma ray photons have higher equivalent mass than radio wave photons, because the whole electromagnetic spectrum can be thought of as photons, even though they have more mass, they're each attracted to gravity at exactly the same rate.
Wow.
It's, by the way, that's called the equivalence principle, advanced by Albert Einstein in 1915. And it's one of the most profound advances in human understanding of the universe that there ever was.
Well, because everyone thought something's heavier.
Right.
It would go.
In fact, the dudes went to the moon. They brought a hammer and a feather. On the moon, there's no air, so the feather is not doing this.
Yeah.
Had the hammer, the feather, let go. They fell at exactly the same rate.
Yes.
And it's the moon pulling on them, but it's just how gravity works.
That's right.
Yeah. So everything will respond the same
I love this.
because it doesn't matter how much it weighs. It's cool.
This is another thing I want to follow up on. I love this
What-
stuff.
what?
I heard we all have our own gravity.
Yes. Yes.
Incredible. That is amazing.
Yes.
I thought it was just people because people liked me.
Yes.
You know what I mean? But
So if I put you out in space and I had like a marble,
Yeah.
and I gave it just the right speed in just the right direction, then it'll go orbit around you.
whoa.
No, a marble, probably like a poppy seed. I need something a
Yeah,
little
maybe
less.
something like that.
Yeah.
Oh my goodness.
Yeah, so we can make at least some of the universe orbit you. If your ego needs it.
I know. Listen, my wife believes I have my own gravity. She's like, it's called narcissism, is what it's called.
So the real way to say it is you and the Earth attract each other.
Yeah, yes, that's great.
That's what's going on.
That's it. That is so beautiful.
Right. So if you jump off a cliff and you fall to Earth, what's actually happening is you and Earth are falling towards each other, except you're doing most of the moving.
Yeah.
Earth will come up just a little bit to meet you. Yeah.
I love that.
Yeah.
Dude, that's so good.
Okay, keep going.
Here we go. Samuel Tomka. Hello, Neil and Terry. Samuel here from Slovakia.
Nice.
All right.
I'm embarrassed as an American. I just an geographically ignorant American. I was asking someone from Slovakia, like, what was Slovakia before? It was Slovakia. Because growing up, I don't remember hearing that, right? And she said, oh, it was part of Czechoslovakia.
You know what? Yes.
It's like, duh. Well, then I asked another stupid question. I said, well, so what was the rest of Czechoslovakia? Oh, that became the Czech Republic. Okay?
Yeah,
So
it makes all the sense in the world.
It's like, okay, duh.
Connect the dots here. But yeah, I believe me, I would ask the same question.
Okay.
Believe me. I have a question. If humans settled on a low gravity planet, would skipping leg day have an entirely different meaning? Or would we have to invent new exercises just to keep our legs from shrinking? Keep the fun and education going. Love you guys.
I love it. So
I've been accused of skipping leg day a lot. These skinny little legs.
I can give two answers to that.
Okay.
One of them is if you want to maintain the physique that you would have had on Earth, yeah, you're going to have to exercise way more. And you have to use exercises where you can add resistance beyond just lifting things off the ground. You need like pulleys and things. And so that's if you wanted to do that. But if you will forever be living on that low gravity planet, you don't need the big muscles anymore.
You don't. And I heard you get taller.
Yes. In fact, you get tallest if, do you know that astronauts that do spacewalks, which NASA calls extravehicular activities, I'm trying to get them, dude, just call it a spacewalk.
Yeah.
Just
Extravehicular.
Okay. EVAs, they call them. Okay.
Okay.
So astronauts have spacesuits, depending how tall they are when they're launched, 2 to 3 inches taller for their spacewalk than they do for when they launch.
Oh my goodness.
Because in 0G, they grow.
They just grow
You
into
can
it.
grow, if you're 6 feet, you can grow 2 inches.
That's crazy.
Yeah.
I want to go to space. I'm going to look amazing when I come back.
So
Terry,
your vertebrae,
6'7".
No, it's not. So it doesn't keep going.
Okay.
So your vertebrae expand because you don't have gravity compressing them.
Yeah.
And you get a couple of extra inches. So they can't spacewalk in the same suit that they launch in.
Oh my goodness.
Yeah.
I bet you zero gravity is good for my skin too.
It's good for everything.
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 I love it.
Yeah, everything just kind of floats there. Yeah. So like I said, if you don't need your muscles, they will atrophy. If you never need your muscles, should we care that they atrophy?
That's
I
right.
don't know.
That's right.
But if you ever want to come back to Earth, you better be ready for that. And the astronauts come back to Earth, and they got all kinds of machines up there so that they don't lose their muscle mass.
Yeah, because you can get really hurt.
And you can still lose bone mass. There's still a unsolved problem, the bone part.
But you can be a blob in space. That'll be great.
You can be blob in space, and your heart won't even know the difference because it's not pumping against gravity.
That's good.
Yeah, you don't want to clog your arteries. But you can be chubby. But if your arteries were still clear, your heart won't even know.
This is a great question. That was a great question.
Okay, give me another one.
Daniel Frank. Hey guys, love the show. He doesn't say where he's from, but
Another
witness protection. If one was able to stop time, is it true that you wouldn't be able to see anything because the photons would freeze too? Can we make an exception to that?
I don't know if I have a good answer for that. No. Because to the photon, there is no time. You might have heard that the faster you go, the slower time ticks. This is relativity. And in the limit, at the speed of light, time stops.
Yeah.
Photons, which exist at the speed of light, when they are emitted at wherever they came from, my PhD thesis was on the center of the galaxy, which is 30,000 light years away. And when I captured those photons, for me watching them, they took 30,000 years. But if you're the photon, the instant you left the center of the galaxy, you hit my detector.
You're right there.
In the same instant.
Yeah.
So if there's zero time, I don't know what effect that would have on the photons.
Right.
Because they don't ever have time.
Yeah, they're outside of time.
In a way, they're outside of time. Wow. In that sense. So I'd have to think more about it. I don't have a good answer for that.
I feel like, a fish floating in water
doesn't know it's in the water.
Know it's in the water, so to speak.
Yeah.
You know what I mean? And that's weird. That's really wild.
Would a photon know that time had stopped?
Ooh, that's a whole nother deep question. Oh, we just opened a wormhole. My brain just went tilt.
Yeah, so I don't know.
I love this.
Oh, by the way, that was a very dated comment you made.
What?
You said tilt.
I did. I know.
Oh my gosh.
I know. That's
Terry.
Pinball wizard.
Pinball
wizard. I know. My kids try like, what?
If you try to influence the ball, you like hit your hips into the machine. If you do that too much, the game craps out on you and it says tilt.
Well, I tell my kids, I'm like, I'm trying to read. I want to make myself so interesting. I could read the phone book and be wonderful. And they're like, what's a phone book? What are you talking about? I'm going, oh man,
you're already
so
not interesting.
Oh,
all right. You should have a few more in there.
Yeah,
right?
well, it's more. This was Mickey Pastillo. Mickey from Omaha here.
Omaha.
Which flavor on Hot Ones was the hardest for each of you? Thanks.
Oh, you on Hot Ones?
I was on Hot Ones.
So was I. Oh my gosh.
Oh, I was high on Hot Ones. It made me literally. I've never been on drugs. I've never been drunk before in my life.
Okay,
dude, I was hallucinating.
Oh,
it was so painful.
Okay,
that I started to see double.
No, I spent 6 years in Texas, starting out a complete wimp and leaving where I could eat a jalapeno pepper and not tear. So I had some bit of, I don't want to call it training, but life experience. So there were 10 of them. Where did you start crapping out?
Oh man, I went all the way.
You went all the way.
The last dab hurt so bad.
Okay.
Now you have to understand too, because I do intermittent fasting. That was my first meal of the day.
Ouch!
That made it triply. I would say it.
Wait, just take a minute.
Everything up.
Take a minute. Tell everybody what Hot Ones is, in case they.
Hot Ones is a show that you basically taste different hot wings at different levels. They're buffalo wings at different levels of heat. The sauce was from mild all the way to the most intense heat you could ever
up to mega death.
Yeah, where these ghost peppers. They have all these names for each one of them.
Some of them are not even found in nature.
Yes.
They became this contest.
They genetically modified peppers that were like, oh my God, like nuclear.
Is that what our GMO scientists are coming up with?
Chernobyl level.
Yeah, and so I think the premise is you're allowed to talk about your projects to him, but only if you can get through the sequence of heat.
I had heard another experiment where it's hard to lie when you're doing something else. So they would make you hold a ball, bounce a balloon in your hand, and then they ask you questions. And you can really tell who's lying and who's not.
Interesting. I never knew that.
And I think that's the premise behind Hot Ones, because
everyone there is really honest.
you have like to think through all of the what's going on in your face.
And you know they're honest because they're people who otherwise have their relationship with a camera and it goes completely out the window.
I was screaming. I literally had to yell, just to keep my brain from just like, okay, or running out of the room. Because I knew I wanted to stay in it, but I was like, it's hard.
So I was good up to 8 out of the 10. And then 9 was pretty severe. I already knew you're not supposed to touch it with your lips because then your lips get, you can't feel your lips.
Did they give you a little milk and all that stuff?
Yeah, I did ice water, but milk would work too. But I went to 10 and then I took a double dose because I said, I got to do this.
Oh my God.
But here's what happened. Here's what nobody told anybody. Did you fly into New York to do it?
I did.
Okay, because I just took the subway, okay? Afterwards, I go home. 2 hours later, I had explosive diarrhea. Oh. Okay. 2 hours later. Now, suppose I was on an airplane. Suppose I was in a taxi. I'm in my own bathroom, thank you. And it was like, and I was on the floor. If you never got drunk, this never happened to you in college. In college, you put your cheek on the bathroom tile just to feel the coolness. Yeah. Because you're just.
Okay, I heard about people doing that.
Yeah, this is what it was. And so, yeah, that was my final chapter of my experience.
Hot One's the sequel. Hot Twos. Hot number 2.
No.
Okay, that's really disgusting. I'm just starting a show like that. Okay,
but it was one thing you do once in life, I think, right?
Yeah.
I'm glad
I would never do it again.
Yeah,
never.
That show got syndicated. I think it's on Hulu now.
Oh, and listen, I know yours went viral. Mine went viral.
Yeah, it went viral. Yeah.
Oh, people want to see people they know in pain. They do. Like, oh, look, they're celebrities. They're just like us. They hurt too. I was in tears. I was crying. Yeah. It was crazy. Mm-hmm. Okay.
So, Terry, we've got time for one more question.
You got it. You got it. Here we go.
And I'm sorry, we had like hundreds of questions came in.
This is so awesome.
Sorry, but we just pick them here. All right,
this is beautiful. The last question is from Riley Ruffin. Hello, Dr. Tyson and Mr. Cruz. Riley Ruffin here from Illinois. All right. Mm-hmm. I must say, Mr. Cruz, I love your acting. Thank you. Really a big fan. My question is related to the edge of the observable universe. What observations have been made, and can you describe what it looks like? I have heard that there appears to be some type of haze. Is this true? And can you tell us more about it?
It's a purple haze.
Oh, man. We writing songs right now. I like it.
So, a couple of things.
Talk to me.
The age of the universe is in our way.
The age.
Yeah. So, there's a horizon beyond which we cannot see because the universe isn't old enough for light from objects beyond that horizon to have reached us yet. That's the horizon. It's not completely different from the horizon at sea, where you're at a ship and you see the horizon. Are you saying to yourself, is that the edge of the universe? No, there's probably ocean beyond that.
Right.
And if you sort of sail towards it, more ocean comes into view, and you bring your horizon with you.
Yeah.
That's kind of the horizon is not an absolute thing.
That's true.
It's relative to you, and you are in the center of your own horizon. The exact center. Okay. Now, it turns out, as we look out into the universe, we see the universe younger and younger and younger and younger until we see it just shortly after the Big Bang itself. Right. So technically, that's not quite a horizon. It's a time horizon more than it is a space horizon because you can't see before the Big Bang. And so if you wait a few billion more years as the universe continues to expand, then there'll be a place, a space horizon beyond which you cannot see. And if you travel that direction, again, you can take your horizon with you. Wow. So the real question is, do we really know how big the actual universe is?
Right.
Do you know how big the actual ocean is? Not really.
No.
Unless you keep sailing until you hit land.
That's right.
But if you're in the middle of the Pacific, that's a lot of sailing.
You have no
idea. So generally, when we speak of the universe, it's how big is the observable universe? Yeah. We got to contain it because what's beyond that, We don't know. No reason to think it's completely different. No reason to think just beyond your horizon there's something very different from the water that you're witnessing up until the horizon. No reason to think that. So too with the universe. Beyond an observable horizon, no reason to think the rest of the universe is fundamentally different from what's within our own horizon. And so, by the way, everyone sees themselves as the center of the universe.
That's true. That's true.
Which means there is no center of the universe.
Yeah.
And one of my most retweeted tweets, I guess it's X now, it was very simple. I said, because the universe has no center, it means you can't be it.
Now I'm disappointed. Now I'm very disappointed. Because I always thought I was the center of the universe. But you know what? I got to add one more thing.
What's that? Okay.
And what's so crazy is looking at how endless it is out there. I often wondered, is it as endless in here? Meaning, is there an end as you go inside
the mind?
Inside
the atom?
This atom. Like,
okay, for a while there,
Wow.
people suspected, because they wanted it to be true, that you see the sun and you see planets orbiting the sun.
Yeah, it's
when
like
we first,
are we an atom?
Exactly. So when we
Yeah.
first cracked the atom, they said, wait a minute, there are electrons going around the nucleus. So we borrowed the same vocabulary.
Yep.
We don't call them orbits, but we call them orbitals.
Yep.
Okay, same idea.
Yep.
Right? It's something, and they said, well, if that's what it is, what happens if we go into the nucleus of the atom? Will it be that again, and then that again? Is it that all the way down? No, it's not. It's just not. There's atoms, and then there's us, and this universe. And, not to get too pop culture on you, but in Men in Black, there was the galaxy on the belt of Orion. I don't know if you remember that.
I don't
Orion
remember.
was a cat.
Okay.
And it had a neck
Yes,
thing.
I
And in
remember
there
that.
was this sort of transparent
Yes.
ball, and inside that ball was the entire universe that we are living in.
Yeah.
And it's just this little dangly thing on the neck of a cat. It's fun to think that and write stories about it, but it doesn't look like that's the case. Because different laws of physics apply to the large-scale universe than the small. And if it was the same thing all the way down, you'd see repeated.
That's true.
I think.
The rules don't stay the same.
They don't stay the same. They're
Got it.
very different. Very, very different. So it's a fun thought.
This is great. I love this, man. I love this. I could do this all day.
Okay, so
love it.
All right, let's make a deal.
Yes.
Any future time I'm in Pasadena, we'll fire up the hearth and we'll do this again.
Let's do it. Let's do it. I love
Okay,
it.
it's a permanent Pasadena date.
Absolutely. Absolutely. Or I'll meet you at Caltech. It's no problem.
Okay, that
I'll
can
walk
happen.
over there.
And
No problem.
just quick, you had a very successful memoir because your life was
Yes.
so interesting. You shared some of it with me on a previous time you've been on the podcast. Just what your struggles had been from pro football, and you were not quite homeless, but you were destitute for a while, and how fortunes can change if you keep confidence and you have to understand what role failure needs to play.
Yes.
There are people ready to give up, and I say, no, that should be the force that drives you forward.
Listen, the book was called Tough, and it was about
It
finding
still is. It's on shelves. I've seen it.
it's about
I've
finding
seen
your
it.
true power, and literally, it's really the power of choice. Choice. The only thing you can control is you. That's it.
That's so simple that it's deep.
Yeah, and wait, it took me years to find that out.
Okay.
Because I was a professional victim. I mean, looking at all the circumstances of different things and the
We all
wins
know
and
people
this,
like- we
and
all
you
know-
did. Hey,
Your fault, and how come I didn't? Because you didn't. Professional victim. I like that phrase.
dude, everything revolved down to my choices, and I realized that, and that really opened the way. It was so, like you said, it's so simple, it's deep.
Yeah.
Simple doesn't mean easy.
No, it doesn't. It doesn't.
That's the big thing. A lot of people think simple and easy is the same thing. But
It
it's not.
doesn't. And one last thing, I was channel surfing, and there's like the animated.
Yes.
Everybody hates Chris.
Yeah,
Did I hear your voice still in
Listen,
there?
you
My ear
did.
bent.
You did. It just came out. I'm so
Everybody
happy.
hates Chris. So-
Everybody still hates Chris
Because that's the sequel.
It's a
But it's an
sequel.
animated sequel.
and it literally
That's audacious.
It picks up where The live action show left
And you
off.
got all the characters come back for that.
All the
Oh,
characters
except for we lost one.
Tyler James Williams is an adult, so
Okay.
a lot of those kids grew up.
Yeah, of
so we
course.
have new voice actors for the kids, but a lot of the characters who were adults at the time did come back.
Yourself included
Me,
as the dad.
Tashina Arnold,
Yeah.
Chris Rock,
Okay.
Jackie Harry,
Yeah, of course,
Ernest
Chris.
Thomas.
Right.
It's amazing.
And Chris is the narrator because
That's
it's
right.
his life.
It's his
okay,
life.
we look forward to that.
Thank you.
Dude.
Thank you.
Oh, and of course, star host with shiny suits on AGT.
Yes. Oh, and don't forget Killer's Game.
Killer's Game.
My movie is going to be
A
out
movie?
on demand. I did a movie with Dave Bautista.
Okay.
Where we were like assassins. We had our own app where you could. It's like the Uber for assassins.
What?
It's an action comedy, by the way. So have a great time.
Dial of an assassin comedy. Okay.
You can get an assassin anytime. Just Uber it. It's kind of like, oh yeah, look at this.
Okay.
You
now
rate your assassin.
I got to tell
then you
all
do
of
a
our
good job.
people, give them a friendly face. Give them
Yes.
a friendly face.
Fine.
And I'll give them a don't f with me, I'll kill you face.
That's how you do it. I've been doing this forever.
All right, we out. Terry, love you, man.
Love you. I love you,
Okay.
brother. You're the man.
This has been another edition of Star Talk Cosmic Queries with special guest co-host Terry Crews.
I love you guys.
All right, until next time, I'm Neil deGrasse Tyson bidding you to keep looking up.